Hi class, today we are on Saxon Math Book 4, Lesson 72, and we will be talking about finding information to solve problems. So we're speaking about word problems here, and the tricky part about word problems is that you have to be just as good of a reader as a mathematician when you're solving word problems. You need to know where to find the information you need. You need to be able to discern what exactly the question is asking, what it's asking for, what it's asking you to do, and that is what tends to make word problems tricky. So we are going to look at a couple together. I have the first one here. I want you to be able to see what it says as much as hear what it says. So it starts with, the school elections were held on Friday, February 2nd. Tahana, Lily, and Tariq ran for president. Lily received 146 votes, and Tariq received 117 votes. Tahana received 117 votes. Tariq received 35 more votes than Tahana. So, there's no question in this one to start. We are just going to identify different bits of information that it gave us. So my first question to you is, how many votes did Tariq receive? Does this tell us? So let's look again. It tells us right here, Lily received 146 votes. Does that tell us how many Tariq received? No. Tahana received 117 votes. Does that tell us how many Tariq received? No. Tariq received 35 more votes than Tahana. Does that mean Tariq received 35 votes? No. It means he received 35 more. How do we show more than with math symbols? Are we going to add, subtract, multiply, or divide? If he got 35 more, we need to add 35 votes to whatever the starting number was. Okay? So I'm going to highlight that information because that's a key bit of information in this problem. Tariq received 35 more votes than Tahana. So in order to figure out exactly how many votes Tariq received, what other piece of information do we need? We need to know how many votes Tahana received. So if you look up here, it says Tahana received 117 votes. I'm going to highlight that as well. Right there. So now we have all the information we need to be able to add 35 to the 117 votes Tahana had. 7 plus 5 gives us 12. 3 plus 1 plus 1 is 5, and 1 plus nothing is 152. So 152 votes for Tariq, T-A-A-R-I-Q. Okay, 152 votes. The next question is, who received the most votes? So we couldn't answer that until we figured out this, all right? We know Tariq now got 152. We know from the problem that Tahana got 117. And we know that Lily got 146. So I'm going to go highlight that as well. So between 146, 117, and 152, who got the most votes? Tariq. His number is the highest. There's one more part to this question. it says, speeches were given on the Tuesday before the elections. What was the date on which the speeches were given? So we need different information for this one. Here's our problem again. It says the school elections were held on Friday, February 2nd. And they want to know when were the speeches given, if they were given the Tuesday before. So I just highlighted that last piece of information. Friday, February 2nd is what we need to know. So I would say my strategy for a problem like this is I almost make a calendar. I'm just going to put Monday through Friday. Monday, Tuesday, Wednesday, Thursday, Friday. I know that February 2nd was on Friday. I need to know what was this day, this Tuesday before the Friday. So if this was the 2nd, this would be the 1st. What comes before February 1st? Well, January comes before February. What is the last day in January? So that's where you have to know how many days are in each month. January, 30 days hath September, April, June, and November. All the rest have 31 except for February. So where does January fall in that? January has 31 days. So this day, this Wednesday, would be the 31st of January, which would make the Tuesday, we're going to count backwards here, the 30th of January. So when were the elections held? I'm sorry, when were the speeches held? January 30th would be our answer for that part of the question. Okay, so that's all we're going to do with our election question. I'm going to move on. I have another one here that I want to show you. So this one's about Alyssa. Alyssa collects keychains from the different states she has visited. I'm trying to read it backwards. Let me read it from the book. Alyssa collects keychains from the different states she has visited and displays them on a pegboard. So then this is her pegboard. These are the 5 states that she has visited and how she has them displayed. So then down here. Since Alyssa lives in Nebraska and her grandmother lives in Ohio, she always keeps the Nebraska and Ohio keychains on the first 2 pegs. How many different ways can Alyssa arrange the keychains in one row? So she has these 5 keychains. However, Nebraska and Ohio right there, they are always on the first 2 spots. She's never going to hang Texas here. She's never going to hang Maine or Florida in those first 2 spots. So we're dealing with a combination problem. How many combinations can we make? So I'm going to make 5 slots. 1, 2, 3, 4, 5. Okay? But these 2 are always Nebraska and Ohio. I'm just going to use the first initial so I don't have to write it out every time, okay? So these 3 can switch, but it's going to be Texas, Maine, and Florida that we're switching. So Texas can go here, Maine here, Florida here, or I can leave Texas in the middle spot and flip-flop Maine and Florida. This is called making an organized list. So I start with Texas, then I think of how many other ways can I organize this if Texas is right there. There's only 2 because I can only flip these back and forth. So now let's put Maine here. Let's say I have Maine in the middle and then I put Texas and Florida here. That's another option. Or I can leave Maine in the middle and flip-flop Florida and Texas. Finally, I can put Florida here in the middle spot, and I can put Texas and Maine, or I can put Florida in the middle spot and have Maine and Texas. So these 6 combinations are the only combinations that I can do with these 3 states in these 3 spots. But look what else I can do. I can have these with Nebraska first and Ohio second, the whole way down. So there's 6 combinations with Nebraska first and Ohio second. But can I flip-flop Ohio and Nebraska? Can I put Ohio first and Nebraska second? Yes, I can. Ohio, Nebraska, the whole way down. Because it says that Ohio and Nebraska are in the first 2 spots, but it doesn't say that Nebraska's always first or that Ohio's always first. So I have 6 options like this, or I have 6 options where Nebraska and Ohio are flipped. So how many total combinations does she have for hanging up her state keychains? 6 plus 6 gives us 12 total combinations for that question. Okay, this next problem is your lesson practice problem. So once I hold it up to the screen, I want you to start trying to answer it on your own. Okay, I'm going to hold up the problem and you are going to try to find the answer to the questions. So hit pause if you need to before I give away the answer. So the problem says, Terrell did yard work on Saturday. He worked for 3 hours in the morning and 4 hours in the afternoon. He was paid $6 for every hour he worked. How many hours did Terrell work in all? Think about that. Write down your answer on a piece of paper or whiteboard. We'll talk about it at the end. The next question. How much money did Terrell earn in the morning? Just the morning, how much money did he earn? The next question says, how much money did Terrell earn in all? So the whole day, how much money did he earn? Okay, so question A, how many hours did Terrell work in all? Well, it tells us he worked for 3 hours in the morning and 4 hours in the afternoon. Here we've got that highlighted. So how many hours did he work? 7 hours. How much money did he earn in the morning? So we know that he worked 3 hours in the morning, and we need this piece of information. He earned $6 for every hour he worked. So he worked 3 hours. He got $6 for the first hour, $6 for the second hour, $6 for the third hour. So he made $18 in the morning. How much did he earn in all? He worked a total of 7 hours. He got paid $6 for each hour. So this time we'll turn it into a multiplication problem because I don't want to count by 6 7 times. I'd rather just have it memorized that 7 times 6 equals 42. So he earned $42 for the day. Okay, the final question that I have for you today is with a picture. We have a quarter, a dime, and a $50. And my question is, how many different amounts of money could you make using any two of the 3 coins shown below? Name the amounts. So hit pause, try that one on your own right now, and hit play when you're ready to see the answer. How many different amounts of money could you make using any two of the 3 coins? So we're going to make combinations. We can do 25 cents plus 10 cents. We can do 25 cents plus 50 cents. We can do 10 cents plus 50 cents. Is there any other combination that we could do using these 3 coins? In our old problem, we would flip-flop them, right? We would say, well, what about 10 and 25 instead of 25 and 10? But in this problem, they want the total amount of money. So would that change if I would separate 25 plus 10 versus 10 plus 25? No, you'd get 35 cents for either one of those answers, so I don't really need to write it both ways. I just need my total, 35 cents. 25 plus 50 is going to give us a total of 75 cents, and 10 plus 50 gives us a total of 60 cents, so our answer to the final problem is right there. All right, boys and girls, that was your lesson practice, so you should already have that completed. Now it is time to work on your written practice, which begins on page 463 of your textbook. I hope you have a great day, and I'll see you soon.